If you are a developer like me, you heavily use Git to track your coding projects, articles, business work, and more. One of the beautiful things about Git is that you can easily compare different states of your work by simply using its built-in diff functionality. Only two constraints need to be met in order to use this functionality. First, you need a Git repository, and second, the file needs to be tracked by the Git repository. But what if you only want to modify a single file compared to older versions, and all of this without the need for having a Git repository? The goal of this video is to create a simple but effective diff tool which allows you to compare two versions of a file without the need of having a Git repository and built entirely upon the Python standard library. Before we jump in, let me quickly show you what we're going to build. So in essence, we're building a simple command line tool which accepts two file paths. So here in this directory, I have 4 files. I have the diff tool, I have a shopping diff HTML that we're going to generate in the end, and we have 2 txt files. So one is the shopping list of a friend, and one is my shopping list, which we want to compare. So let's see, Python diff tool, and simply pass my shopping list and friend's shopping list. And as you can see, we get a diff, which shows us that cheese is occurring in both text files. My text file contains tomatoes. The one of my friend contains tomatoes. That's why it is marked here as a difference. And furthermore, my friend has also specified salami. You can also see that I have a blank line at the end of the file, whereas the other file doesn't contain a blank line at the end. Okay, but that's not all. We can also export this to an HTML file by passing a parameter HTML and specify the file. For instance, shoppingdiff.html. Now nothing is printed to the terminal, and if we open the shoppingdiff.html, we can see that a nice overview was created for us. So over here we see the content of my shopping list.txt, and as you can see, we have cheese and tomatoes inside of this txt file, and at the end there is a blank line. On the other hand, the friend's shopping list does also contain cheese as the first ingredient. Then instead of having tomatoes, we have tomatoes. That's why we have here an additional character. And on the third line, there is no blank line, but instead the word salami. Additionally, we also have a legend over here, which shows us which color stands for what. All right, that's pretty much it. Let's continue by creating a new directory. So let's go to my temp directory, create a new directory, Diff-Tool without the solution at the end, and go into it. So as you can see, there's nothing in here, but we need the 2 shopping lists, which we want to compare. So Diff-Tool solution, we need my shopping list, and we need Diff-Tool solution, the friend's shopping list. Move both over here. So here we go. And we need a file for our code, and call this one diff-tool.py. Let's open it in Visual Studio Code, and then we can start coding. Let's start by creating a simple diff first. The main Python standard library module that we need is difflib. So import difflib. It provides a function called unified diff, which computes a delta for 2 given lists of strings. Let's start with a simple example. So suppose we have these 2 shopping lists, and both are simple text files, and let's now compare them. And before we can compare them, we first need to read them in. So file 1 is open my shopping list.txt, and I also want to use the read lines method of the file object, because it returns a list of strings that we're going to need for our unified diff function. And let's do this for the second file as well. So file 2, open, and this one is called friends shopping list.txt, and also use the readlines method. So now we have the content of both files, and everything that is left is to compute the delta of both files, and this is done by using the difflibs unified diff function, pass file 1 and file 2 to it, and that's pretty much it. Last but not least, I also want to print it to the terminal, and therefore we also import the sys module from the standard library, which provides a convenience function which is called writeLines, which allows us to pass a list of strings to it, which our delta is, and then prints each line to the terminal. So pass in delta over here, and now we can hit over to the terminal and run the script for the first time. So diff-tool.py. As you can see, we already have a pretty printed diff in the terminal. This looks pretty good. However, we don't see which part comes from which file. So if you have a look over here, there is no file name present over here. Fortunately, we can add this information to the delta by passing the file names to the unified diff function. So let's go to Visual Studio Code again, and then we can simply copy this one over here and pass the string to the unified diff function, and the other one as well. So friends shopping list.txt. Let's run the script again. And as you can see, now we see which content comes from which file, or which one is present in both, as it is the case with cheese. At this point, you got the general idea behind computing a delta in Python. What's left is to turn this simple script into a proper command line tool with the option to export it in HTML format too. So first we need to put all of this over here. So computing the diff into a separate function. Let's call this one create diff, which accepts two file paths. So old file, which is a file path, and we need to import it from the pathlab standard library. So from pathlab import path. So we have an old file, and we have a new file. This one is also a path, and we want to return nothing because we want to print it to the terminal at first. So now let's indent all of the other files, all of the other lines over here, so that everything is contained into this file. And now we want to read in the old file first, and then the new file. So new file, which gives us file 1 and 2. And now what is missing is to also get the file names over here, which may also change. And this can be done by simply using the name attribute of the path object. So old file.name and new file.name. All right, that looks pretty good. Next, we define a new function main, which is responsible for the general workflow. So def main. And in essence, we want to build a simple command line tool using the built-in argparse module. So let's import it first. Import argparse, create a new parser equals to argparse.argument parser. And let's don't specify any of these optional information over here. Let's go with the default values. Parser.add argument, and the first argument is the old file version, and the second one is the new file version. Next, we want to parse the args, so parser.parse args. Old file equals to, and now I want to turn the string that is provided by the user, so the file path, into a proper path object. That's why I'm passing the old file version from the arguments list to the path constructor. And I'm doing the very same thing for the new file. So new file, and this equals to rx.new file version. And last but not least, we need to invoke our create diff function. So create diff old file, comma, new file. And the last thing that we need to do is to make sure that if the script is run by the terminal directly, which we're going to do, so if the name is equal to main, then the main function should be called. All right, that's pretty much it. If we head over to the terminal and run the script again, we can again pass 2 file names to it. So if I don't pass anything to it, as I did before, we get an error because we have 2 required arguments, the old file version and the new file version respectively. So now let's pass my shopping list and the one of my friend. And now created diff is not defined. Oh yeah, it's called create diff. Run it again, and now we have the very same result again, but this time with dynamic file names over here. So if we pass other file names to it, they are changed over here accordingly. All right, we are nearly done. What's currently missing is the HTML option, so that the user can also export the delta to an HTML file and view it in the browser. Let's adjust our create diff function first. So it now takes also an argument called HTML output, which is also a path, but this one is optional. That's why we assign none to it by default. Reading in the content of the 2 files doesn't change in any situation. That's why we can leave it over here. But now the next thing that we need to do is to check whether an output file was specified. So HTML output, if it is given, then we want to compute the delta in a different way. And this time we're not using the unified diff function, but instead instantiate a new HTML diff object, which provides a make file method, which takes the 4 parameters we used earlier. So we have file1, file2, then we have the old file's name, so .name, and the new file's name. So it's pretty much the same that the unified diff function accepts. And if the delta was computed, we also need to write it to a file. So with open, and it is called HTML output, open it up in write mode. We want to overwrite existing files, open it as f, and now f.write delta to it because it's a simple string. All right, so this is the HTML part. If the user does not specify an HTML output file, then we want to compute again the unified diff and simply print it to the terminal. So in every other case, this stuff over here should be executed. And that's pretty much it. What's now missing is that we also need to ask the user or provide an optional argument to him, which allows him to specify the path to an HTML file. So over here in our parser definition, we add a new argument. So add argument. This one is called --HTML. And let's provide also a simple help text. And let's keep things simple. So specify HTML to write to. And now if we are over here, so again, old file, new file doesn't change. And if args.html is given, then the output file should be args.html. So then we are converting the string the user provided into a proper path object. If nothing was given, so in every other case, our output file equals to none. And this makes sure that we can always pass the output file variable to the create diff function. And that's pretty much it. Head over to the terminal again. Let's check first if our existing functionality still works. So execute the script again, gives us the same result. And now let's also specify an HTML option here. So HTML equals to, and let's go with output.html. Looks pretty good. Nothing was printed to the terminal. If we have a look at our current working directory, we see that over here we have an output.html file, which was just created. Open it in the browser. Shows us that we have, again, a pretty nice HTML div, which we can compare in the browser. And that's it. Let me know in the comments whether you would use such a tool in your day-to-day work, or you would rather stick to Git or some other version control system. Stay curious and keep coding.